इस वीडियो में हम लोग रिलेशनल डेटाबेस के बारे में स्पेसिफिकली डिस्कस करेंगे. Okay, so we would discuss about representation of data by using relational database model. Then we would also have a discussion about logical data structure, and then we would discuss about features of good database design in the relational database. So what is logical view of data? It refers to the representation of your data which actually resides into the database. इससे पहले भी हम लोगों ने जब भी व्यूज के बारे में डिस्कस किया था, स्पेसिफिकली एब्स्ट्रैक्शन लेवल्स, वी हैड डिस्कशन अबाउट लॉजिकल व्यू. So at that particular time I told you that logical view refers to the structure, tabular structure. So we simply think about, as a database application developer, we simply think about there is a data which is stored into the table, correct? So in relational database model, we refer that particular logical construct as relation. It can also be referred as table. It can also be referred as entity. These are the alternate terms, terminologies, which we can make use of while referring to these tables. However, for the end user, like those people who are new to the database, for them it becomes easy to discuss with respect to table, because when you say table, what comes into your mind is a tabular information, tabular arrangement of the information, correct? And then it becomes easy for you guys to understand. But always keep in mind, table, entity and relation, these all three terms can be used interchangeably. Now when we discuss about table, so it looks like this. So you can see there is a tabular arrangement of the data, correct? It is composed of rows and columns. Now each table row would be referred as record, or it can also be referred as tuple. Each table column would represent an attribute. So say for example, in this case, name is an attribute. Okay, roll number is an attribute, city is an attribute. Okay, and each column is supposed to have a distinct column name. I cannot have repetitive column names into the single table. Okay, and then intersection of these rows and column would help you to provide the value. So if you want to fetch any value, what all things you have to be specific for, about is, you have to know, you will have to be specific about from which table you want to fetch data, okay, then which column you would like to fetch, and for which particular row you would like to fetch. So we refer this particular concept as projection and selection in terms of a select statement, when we will discuss more in detail about it. So at that particular time I'll explain you those concepts again, but just for your information, in order to retrieve a value from the given table, you need to know about which attribute you need to refer for, as well as from which particular record or from which particular row you want to pull out this value. When you think about column values, so there are some restrictions as well. So all the values which are stored into the column, they should have to follow the common data format. Say for example, you have defined one of the column as date, so each row should contain date type of a data type for that particular column. Order of row and column is actually immaterial to the database. Database को कुछ फर्क नहीं पड़ता कि आपने कौन सी जगह पे कौन सा कॉलम प्लेस किया है या फिर रोज को कौन से सीक्वेंस में अरेंज किया है. डेटाबेस को फर्क पड़ता है what value is stored and what attributes you are referring. Okay, so in order to fetch a particular value, or in order to identify a particular row from the given table, you need to have key. So that's why it is recommended, specifically when it comes to the relational database model, it is must to have some primary key, or maybe for that matter candidate key also you can refer, which can uniquely identify each row. So we have a separate video just for the discussion of keys. So in case if you are not clear with the keys concept, you can have a look at that video. That's the next video. Okay. Now what are the different features of the good relational designs? So if you say that you have developed relational database model, you have actually implemented, how will you judge that you are in the outcome, whatever you have come out along with? So how come it is good one? So there are certain characteristics which are expected out of it, correct? So very first thing is since you are referring to the relational database model, your data should be arranged in table format. That is nothing but in the format of rows and columns. That's the very first condition. Whatever records you're storing into your table, you should be able to fetch data from those particular data or from that particular table by using SQL language. So you should be able to manipulate data very well. Each relational database should have these four stages. So what are those four stages are? Like you should have to first define what are the tables, what are the attributes has to be there. Then you will have to identify the primary key. If you have multiple tables, in such a cases, you need to define the relationship between those tables, and then finally you should also apply the normalization so that you can come out along with the good relational database design. It is also possible to generate set of relational schema directly from the ER diagrams. So in the previous videos, we have seen how to create ER diagrams, correct? So if there are certain rules by using which you can convert those ER designs into the relational schema as well. However, sometimes you will also have to check by applying normalization or the normal forms whether that database design has come out as a poor structured data or whether it has got well structured data. So it is always good practice that if you are using ER diagrams, you apply the rules to convert it into the relational one, and then you should apply normal forms to do that. So we would be having a separate video on how to convert ER diagram into the relational model. So within that video, you can have a look at what are the different rules are there. Now obviously, whatever database design which is coming out as an outcome here, that completely depends upon how good your ER diagram was. So when I say how good my ER diagram is, that means आपने ER diagram में कितनी entities को identify किया? Have you identified proper relationships between them? What are the cardinalities which you have identified? Have you identified correct things? If you have done the ER diagram design correctly, after that relational design would also come out as correct one. But if there are any mistakes into the ER diagram, definitely उसका जो outcome होगा उसमें भी mistakes ही आएंगे, correct? So you have to be a little bit careful about this. Relational database storage structure or the representation of information is different than the other databases and other models as well. Okay, so there is a difference between how do the relational database model would organize the information and how it will retrieve those particular information when as and when it is required during the transactions. So it has got its own way. When you think about relational database design, so in such a cases, your data is organized into the table as well as it also complies that the whatever transactions are there, no, those are the control transactions. They should have a proper behavior, they should have proper characteristics. So relational database design makes sure that your database design also satisfies the ACID properties for the transactions. Relational database design also mandates that for your application implementation level, you should actually keep your database server as a separate node so that while dealing with your applications and all, it becomes easy to retrieve data from the centralized server. So let us try to understand how do we identify atomic domains while working with the relational database model. So as we just now discussed, ER diagram or ER model would also allow to implement the relational database design from the ER diagrams, correct? So it also allow you to define entity sets along with the relationships and the substructure degree as well. So it can have certain restrictions on, or it can have certain set of rules which will guide you how many substructures you can have. Specifically, these questions would come along with the multi-valued or the composite values. So let's say if you have a multi-valued attribute, a customer can have multiple contact number. I would prefer to store it as a multi-valued attribute, correct? Now, what happens is when you try to create relational schema from this ERD, at that particular time, it is recommended that you should create a separate table to store those multi-valued attributes. Okay, similarly, if there are any composite attributes like as an address, which can have street, city, state, as well as zip, so it can have sub attributes as well, correct? So what we recommend is that you should actually create the altogether separate table to store the structural or composite attributes as well. Now, while you're trying to eliminate these substructures, that time you're making sure that your relation is going to be an atomic domain, or it is going to be an atomic relation. Okay, so basically what we do is we try to follow the approach wherein wherever substructures are there, like multi-valued attributes or like composite attributes, we are trying to eliminate them. Instead, we are trying to create the separate table so that you can store those values efficiently. Now, once you have come up along with such a relational data design, in such a cases, what happens is you cannot divide your domain attributes into the further substructures, correct? So if you have such a database, if you have such a relation created in such a cases, that would be referred as atomic. Okay, or that could be referred as atomic relation. And this kind of relation is considered that this kind of relation is directly taking you into the first normal form. Because with the ER diagram, if you observe, you identify entities, you identify what are the kind of relationships we have, you also identify what are the primary keys or the key attributes are going to be for your relations. So you are already coming into the first normal form when you actually convert your ER diagram into the relational one. Post that, you can apply remaining normal forms, like you can apply second normal form, you can apply third normal form, and you can bring your database in good shape. So you can have a look at the next video to have a understand normalization process in much detail.